Okay. Oh, I need to get my coffee. What is happening? Coffee. Desperately need me coffee. Okay, Hazeltonians, what is going on, Mr. Nelson here? Straight from the 403 to you. Coffee's in the way. Okay, so right now we're talking about polynomials. We're talking about factoring polynomials, which is essentially the opposite or reverse of multiplying polynomials. And when we are dealing with polynomials, as far as I'm concerned, there's basically 3 steps you need to take. The first being, when you see a polynomial, we need to ask ourselves, one, can we use common factors to factor it? Okay. So that looks like a case of, say I have 3x squared y squared plus 9x cubed y cubed plus 12x squared yz. Okay? And I find the common factors using my factor trees, or just by looking at this. I see that 3 is a common number across all 3. They all have at least x squared, so they have x squared. And they all have 1y at least. So that's the common factor across all 3, and then this times a y gives me 3x squared y plus 3x y squared will give me 9x cubed y cubed plus 4z will give me this puppy right there. Okay, so that's the first thing we should do, common factors. And then sometimes we'll wind up with potentially something in here, but that would be, say x squared minus x plus minus 6. Okay? Or we might just be given a polynomial that's just this. In that case, I can't factor out anything in common. There's no common numbers or variables across all 3 terms in this trinomial. So I can't do any common factoring. So that takes me to my second strategy, which is product sum. And product sum very simply just asks, okay, are there 2 numbers that multiply to make my constant here, that add to make my non-squared variable term there? So I say, okay, 2 numbers that multiply to make, so they multiply to make -6 and add to make -1. Well, yes, those numbers are -3 and +2, so then I can simply rewrite this as x minus 3, x plus 2, or x plus 2, x minus 3. So that's product sum. Very common factoring strategy. You end up doing a lot of that in math and polynomials. Okay, and that's great. But what happens if I have a number in front of my x squared term? So if I have x squared plus 16x plus 5, say for example, but I have a 3 in front of this x squared term, in front of my squared term. Well, I can still use product sum, but I kind of use a modified version of it, and it is called the decomposition method. Okay? So product sum I use when I don't have a number in front of my squared term, so if I had something like this, I don't have a number in front of my squared term here, so I can use product sum, potentially. Or I guess, but if I do have a number in front of my squared term, I can use decomposition. So that would look like this. Say I have 3x squared plus 16x plus 5. So to use decomposition method, It's very similar to the product sum, but there's a different step at the beginning and another step at the end. So at the beginning, what I'm doing, instead of just looking at this number and saying two numbers that multiply to make plus 5, I'm actually going to multiply my x squared constant with my regular constant here. So 3 times 5 is positive 15. So I want two numbers that multiply to make positive 15 and then add to make positive 60. And those two numbers are 15 and 1. So now, if this was just straight product sum, this would have been my answer. It would have been x plus 15, x plus 1. That would have been my answer for this product sum. But that's not quite the case here. So what I do now is I take the 15 and the 1, and I replace 16x with 15x and 1x. So I can do this, 3x squared plus 15x plus 1x plus 5. So the 16x has become 15x plus 1x. Still the same things, it's still the same expression, just broken up. And now what I do is I put a dotted line down the middle here, and I factor these two, this binomial, and I'm going to factor this binomial. Now, I could have put 1x here and 15x here, and it would have worked out the same, and I'll show you that, but for now. So, I'm going to factor this binomial, and I can see that I have a 3x in common. So, x plus 5 here. And then on this side, I'm going to factor this as well, and I can pull out a positive 1, x plus 5 as well. Now, I want whatever's in brackets to match. And they do here. And in that case, we get 3x plus 1. Sorry. To get an answer out of this, I can remove the dotted line. And now my answer is going to be 3x plus 1 times x plus 5. Now, why is that? Well, this is basically a binomial with a binomial inside. Okay, so there's an expression separated by a positive sign, and then within it we have a binomial as well. But what I'm doing here is essentially I'm saying, okay, well, I have an expression here, and I'm going to factor it now. So I'm just going to say that, say some letter, say z, I'm going to replace z with x plus 5, or x plus 5 with the z. So if I rewrote this in that fashion, I would get 3x times z here, plus 1 times z. And now I'll factor this, and I can pull out a z, and I get z times 3x plus 1. And then if I replace x plus 5 with my z, I get x plus 5, 3x plus 1, which is what I have right here. And if I would have written this reverse, so 1x plus 15x, so if I had 1x here plus 15x, you'll see that it still would have worked out the same. So I would have put my dotted line down here, and I would have factored this. I would have just been able to pull out an x, 3x plus 1 here, and then plus 5, 3x plus 1. And then when I would have collected, so I would have x plus 5 times 3x plus 1. Okay? So that is decomposition. Let's do another one. Full disclosure, I have to go to the bathroom so badly, but I don't have editing software, so I have to just keep going. We're gonna get it. We're gonna get the shot. We gotta get the shot. Let's get the shot. So let's do another example of decomposition. Let's say I had 4x squared plus 12x minus 7. Okay, so decomposition. Okay, because it's decomposition and because I have a number in front of my squared term, I have to start by multiplying this number and that number. So I get negative 28. So I want two numbers that multiply to make negative 28 and add to make negative 12, or positive 12. So let's start with positive 28 times negative 1. That gives me 27. Okay, negative 28 times positive 1 would give me negative 27. Okay, how about 28 divided by 2? So positive 14 times negative 2. That gives me positive 12 when I add them. So this is my key right here. So now I'm going to replace this positive 12x with my combination of 14x and negative 2x. So I have 4x squared plus 14x minus 2x minus 7. Now it doesn't matter what order I would have put the 14x and the 2x here, it would have worked out the same. So I put my dotted line to split this into two binomials in my factor. I have a 2x in common here, so I add 2x to make 4x squared plus 7. And then I want this to match over here, so I know I'm going to have 2x plus 7 here. And what do I have to have in front? So I get negative 2x times negative 7. It's going to be a negative 1. So that means, again, my solution is 2x minus 1, 2x minus 1, and then whatever's inside the brackets, which is factored out, 2x plus 7. And again, if I would have replaced 2x plus 7 with a variable, say p, well then I could have written 2xp, 2x times p minus 1 times p. Factor out the p, I get p, 2x minus 1. Put 2x plus 7 back in for p, and I get this expression here. So my answer again is 2x plus 7, 2x minus 1. Okay? Not so bad. If you can do product sum, you can do this. It's just an added step at the beginning and an added step at the end. Why do I drink coffee if I have to go to the bathroom? I don't know. One more example, and then I'm going to go to the washroom. Oh, if I make it, okay. So let's say I have a number like 2x squared minus 3x minus 9. Okay. I have a term in front of my x squared, so I can't use product sum. I've got to jump into decomposition. So I multiply these together, and they multiply to make negative 18. And I want them to add to make negative 3. So let's start trying to figure this out. So negative 18 times positive 1 gives me negative 18, and they add to make negative 17. Positive 18 times negative 1, the reverse, still gives me negative 18. That gives me positive 17. Okay, how about positive 9 times negative 2? That gives me negative 18. And then that gives me positive 7. Not quite, how about negative 9, positive 2? That gives me negative 7. Okay, let's try 3 and 6. Positive 6 times negative 3. That gives me positive 3. Okay, so I've got the right number, so let's switch the signs. Negative 6 times positive 3 is negative 3. Okay, so this is what I need to replace. Negative 6 and positive 3. So I'm going to replace negative 3 with negative 6x and positive 3x. 2x squared minus 6x plus 3x minus 9. Split this into two binomials, and then factor it. So this is, I can pull out a 2x, x minus 3 to get 2x squared minus 6x. And then I need to have x minus 3 on this side matching, so I can factor it out. And plus 3 gives me 3x, and then 3 times negative 3 gives me negative 9. So then my answer here, as I do the p-dex, is 2x plus 3 times whatever's in here, x minus 3. Okay, and it wouldn't have mattered if I could have switched. I could have done this. I could have done plus 3x minus 6x here. Plus 3x minus 6x, switch the order, and it would have worked out the same in the end. It would have, so I could have done x, 2x plus 3, and then 2x plus 3 here. It would have to be negative 3. And again, x minus 3, 2x plus 3. That is decomposition. That is going to be one of your best friends in terms of factoring. As we move forward, if decomposition doesn't work, then you're just going to want to use your good old-fashioned quadratic formula, which in grade 10 we have not learned yet, but in grade 11 we have. So that would be step 4 is pull out the big guns, okay? Have a great day.